Hello everyone. My name is Casper Julius, and we I'm going to do a final. I'm going to do a final presentation about my AI model that I've been working upon for the whole of this series that I've been uploading. Yeah. So basically, today we are going to just discuss how I created my model, trained it, and how I came up with how I did my data cleaning and splitting and actually doing um, the model selection, the metrics that I followed, everything about that. So to begin with, my project is all about digit recognition, and within digit recognition, we aim to recognize handwritten digits using machine learning algorithms. And the purpose of this project is to demonstrate the effectiveness of machine learning algorithms in recognizing handwritten digits, like from 0 to 9. So, and to help us come up with this model that predicts digits, we are going to use the NIST dataset, which is most used for handwritten digits prediction. Yeah, so it's the most used data set. So this data set is a collection of 70,000 images. So it has images with handwritten digits, and these images are grayscale images, and they have different forms, different ways of digits of handwritten digits by different writers. So, and each image is 28 by 28 pixels. And so our data set, as you see on this other screen of the code, I first loaded the data from the CSV file in Kaggle, and after loading the data, I had to combine it because the data set is split into training and testing sets, which I needed to form to have also the validation set. So I had to first combine the data into a single data set and then later split it into train, validation, and then test sets, as you see the code below. So to demonstrate, yeah, so I split my data set into 60% training, and then 20% testing and 20% validation. Um, so in total, we have 70,000 images. So after the splitting, the 60% training remained 42,000 images, and then for the training and the testing, each of those used 14,000 images. And show an illustration of how I did the splitting and checking. Oh, wait, it's the screen. So if you see this image down here, right here, the count, if you look at the count here, this is a number of images that I have, 15,000 images for the validation. And for the training, I have 42,000 images. And for the testing, still have 40,000. Yeah, so that's how I split my data set. And to begin with, I had to prepare my data that is in the data set to make sure that it's clean enough to be used in my models. And so that I had to enhance the quality of data that I had and ensure that I was having clean data so that I reduce computation costs, like, the time, computation time and everything, and also reduce overfitting. So I pre-process the data by normalizing the pixel values to be between 0 and 1, and then replace the shapes to be pixels 28 by 28. So an illustration of here's an image of a raw image, and after pre-processing it, how it looks like. It's almost the same, but in actual sense, I've done something about it. So I've done some preparation about it, and yeah. So also I tried to check up which images to get the number of images for each of the features, for each of the numbers. So as you see the graph here, I found out that the biggest class was digit one. Digit one had over 8,000 samples in our data, and 5 had less. If you see here, the graph 5 has less images. So in our data set, 1 has the most images. As you see the graph, it progresses through the other numbers, and each number, the images of each number correspond to their given amount of samples given in this data set. So 1 has the most and 5 has the least, and the rest are in between there. So to continue, let's continue I did some explanatory data analysis, but I explained that in the previous videos. So, and the code I'm going to share the code with you in the link. So I did some box plots and everything. So some outlier checks and correlation matrices. So I have explained that in the previous videos, heat maps and everything. So let me jump ahead to go and talk about the model. So for the model, I had to do for some data cleaning to ensure that there are no missing values in these data sets, and surely there were no missing data sets. If you see this heat map, it illustrates if there are any, if there are any null values in our data set, but the heat map is blank and there's no missing value. So I'd first ensure that there's no missing value. I did some data cleaning where I normalized the pixels. I've talked about that, flatten the data to match the expected input shape for the algorithms that I'm going to be using to create my model. So I had to first do some data cleaning. And for the model architecture, I've actually used five algorithms to compare and see which one is the best. So for I used the SVM model training, and I use SVM algorithm. I also use KNN. I also use the CNN algorithm to come up with my model. I also use the logistic regression, and I also use the random forest algorithm. So let me just talk about the CNN model, which is the most used, and but for my case, actually, when I tried all the algorithms, SMV gave me the gave me the highest accuracy, and I considered it to be my best model. So it was giving me more correct predictions than any other algorithms. It had a higher accuracy matrix. So The model, before actually, we are going to train our models, all of them, using them in this data set, as I've said. And yeah, so after training our model, we have to test it on the test data that we already, on the set that we already got, and also validate it on the validation set. So yeah, some of the curves, training curves that I came up with. So as you see, these curves, they show a loss and accuracy, model accuracy and model loss. This is a sample of those graphs, and I've done it on the CNN model. So I try to also come up with model evaluation. So in a model evaluation, this is the process of assembling a performance of a machine learning model on a given data set. So it's a very important step to note in the machine learning workflow, because it allows us to understand how well the model is, how the model is working and how is it really able to predict. So we want to know if the model is doing it right, if it's predicting, making true predictions or false prediction, and how is it performing. So I want to test its performance. So this is model evaluation. And actually, once we have trained our model and validated it, so we have to test it on how it performs. And here I did I used the confusion matrix, and here sample images right here. So for each algorithm, I was doing a confusion matrix, like for, let me share an illustration here. So here is my confusion matrix. As you see below, that's the code for confusion matrix, and here are the sample images that are in that confusion matrix. So if you see here, there's a predicted label and a true label actually. So if you look at CMV, it's predicting everything right. 7 predicted 7, and the true label in that image. Predicted 7 still 7, 6, 6. Predicted 1 for 1, predicted 8 for 8. But if you see some other models, let me go to maybe CNN model. CNN model. The CNN model, I try to do a confusion matrix to see how it performs. And you see here, it predicted 1, yet the true label was 8. So it made a wrong, a false prediction here. 1, 1 was true, and then predicted 1, but it was a 6. Predicted 1, but it was a 7. Predicted 1, but it was a 7. So CNN is making more errors. It is having less accuracy in prediction. But if you look at the CMV, as I've shown the confusion matrix, it's predicting almost everything right. But if you see this, it's predicting 1 for 8. It's actually predicting 1s for everything. So it's making more mistakes than any other model. If you look at random forest, is it? Yeah. If you look at this random forest, it's trying to predict some levels, right? Yeah. But the most accurate, after everything, I tried to choose which model was the best, basing on their accuracy. And here is the code that helped me come up with a best model, and the best model was CVM, the model that I trained on the CVM algorithm. And after that, I had to save the model that was the best for me. So as I conclude this, the results for my analysis and machine learning algorithms. I've seen that CVM algorithm gave me the highest accuracy, and actually it's my best model. And I'd like to conclude that These algorithms have a lot of applications, as I've mentioned before in the previous videos. Very many applications, because we want to use this. We want to, in the future work, I want to deploy this model to an application that scans documents, and probably I've written some code that uses the Flask framework to connect the model and the application, so that I can upload an image of images, say maybe scan money, digits, or number plates, something like that. I want to come up with an application that scans handwritten digits, so that I make predictions of the digits, and I come up with a digital form of those digits, come up with the right digital form. So I'm going to be deploying the CMV model because it was giving me more accurate results on evaluation and testing. Yeah, and here are some of the references that I've been using throughout my entire research. And here's the this is the actually the reference to the dataset that I used, the MNIST dataset. Yeah, if you need to, get to know about the MNIST dataset, it has everything. It has all the descriptions of the MNIST dataset. Yeah, thank you for listening, and bye bye.